Welcome, class. This is Algebra 1, Lesson 4.1, Inequalities. So, Chapter 4, Inequalities, and not very difficult. And so, should be a chapter where you can really get a good score and learn quite a bit. All right, we're going to start off with basics of inequalities. We did learn these aspects, a lot of them in pre-algebra, and we'll just take it a little bit further here in Algebra 1. All right, an inequality. What is an inequality? It's a statement comparing two quantities that are not always equal. Not always equal. And I'll explain a little bit more about that in just a moment. Two quantities that are not always equal. All right, let's take a look and think about the symbol. And so in my years of teaching, I've heard all kinds of different aspects for the symbol. You know, you've got your symbol here, and you got that one there, and that one there, and that one there. And, you know, when you look at the symbols, and I've heard people say, oh, they are alligators eating whatever, or, lions eating. And I don't know how you figure out the symbol, but the reality is you have to know what the symbol is. You just have to. You've got to know the symbol, and you've got to get that correct. So make sure that you understand it. In reality, the symbol is an arrowhead. That's what the symbol is. It's an arrowhead. If you think of a number line, we know that negative numbers go to the left, and we know that positive numbers go to the right. So if you, again, the arrowhead, it's an arrow pointing left for less than, and it's an arrowhead pointing right for greater than. Okay, it goes off of a number line. So let's go ahead and fill up the chart here. Again, you want to get these correct every time. So this is a less than because the arrowhead is pointing left. Switch over to my green here. The next one is a greater than. And in this situation, the arrowhead is pointing right. All right, so we put a line underneath. We could have put an equal sign underneath if we wanted to, but that would require one extra keystroke, and we don't need it. When we see that line underneath, we know that it is also the equal to part. So this first one here, C, the arrowhead's pointing left, so that's a less than, and the line underneath says or equal to. Less than or equal to, and then our last one, of course, greater than or equal to. Greater than or equal to. All right, symbols. Again, you got to have it down. You can't mess those up because if you do, you're going to be in trouble. All right, so let's take a look at a property here. Don't get all caught up on this property, but it's pretty simplistic. It's called the trichotomy property. Trichotomy, Trichotomy. And trichotomy, you see that prefix there, tri, that should make you think of three. And it really tells you that there are three possibilities for any two real numbers. So if you look right here, we have A and B. These just represent two real numbers. That's all that means. And there's three possibilities. One possibility of trichotomy is that A is going to equal B. A second possibility in the trichotomy, I'm going to use my green here, is that A is greater than B. And the third possibility of a trichotomy is then, or A will be less than B. It's got to be one of those three. Either the two real numbers are going to be equal, the first number is going to be bigger than the second, or the first number is going to be less than, smaller than the second. Not a big deal. It's the trichotomy property. Three parts to it. All right. Let me go higher here. Number four. All right, so this is something we did not do last year, and it is the aspect of negation. 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 And it's used to signify the opposite of a statement. Negation is used to signify the opposite of a statement. And of course, whenever I think of negation, I have to think of that goofy movie in like the 80s, I don't know, maybe 70s, I don't know when it was. And you know I can't draw, but it had a symbol like this, right? And that's supposed to be a ghost, and I'm thinking of Ghostbusters. But you know that made popular the idea of negation. If you travel in Europe, you'll see road signs with the negation. And so it's that line that crosses it out is negation. So again, how do you negate? It's simply a line through a symbol. It's a line through a symbol. So if you look at the statement, so B says, I'm looking right here, right? B says negate the statement. So we have n less than or equal to 3. How would you negate that? Real simply, just stick a line through it. Just stick a line through it. Now, what does it mean that n is not less than or equal to 3? Well, watch how you write the non-negated statement. If n is not less than or equal to 3, n must be greater than 3. You see what I just did there? All right, well, take a look. Here's the symbol right here. I was going to circle that. It's going to, okay, good. Got away with it. So here's the symbol right there, negated. It's a less than or equal to. To unnegate it, you have to reverse the symbol. So it went from pointing left to pointing right. And if it was an equal to, you have to make it a non-equal to. If it would have been a non-equal to begin with, then I would have finished with an equal to. All right, so let's do a few of them right here. So look at C there, write x is not greater than -2 without negation. X is not greater than -2 without negation. Notice I had the line go in the opposite direction. It really does not matter. I think standard is probably from the right to the left, but it really does not matter. Write x is not greater than -2 without negation. So hopefully, again, you got the x. Reverse the arrowhead. There was no line under, so now you need a line under, right? Pretty simplistic. That's pretty easy. And go ahead and finish up D. And hopefully you're following along now. And now you know to say A is greater than 9, right? Pretty simplistic, the aspect of negation. Okay? So get your symbols correct and be ready for some negation. All right, let's take a look at number 5. For n minus 1 less than n minus 3 less than 1, which are not solutions? So here's a question. Yeah, they give you an inequality right here, right? And they ask which are not solutions. Now, what are these three numbers? We've dealt with this before. A word should come to your mind when you see these three numbers, and I hope the word domain comes to mind. What are the domain? What is the domain? The domain are the values of the variable. Okay, they are the values of the variable. So really what we have is three problems in one, and we're going to check to see if indeed each one of these is a solution. How do we do that? We take the original inequality where the variable is, we sub in our value of the domain, and we're going to see if we end up with a true inequality or not. So this one, 2 minus 3 is a -1. Is -1 less than 1? It is. That's true, so this is a yes, because that was true. We'll do the second one. Same scenario, take the original inequality, where the variable is, sub in the value of the variable. All right, so now we end up with 0 is less than 1. Again, this is true. So let me write it this way. True, so therefore then this is a yes, right? As long as the statement is true, then it is a yes. Here, let me go over here to the right for C. So again, and I always put a parentheses where my variable is, -3, less than 1. Stick in the value for the domain. 4 minus 3 is 1. 1 less than 1. Is 1 less than 1? And that is false. 1 is not less than 1. Now, if this would have been a less than or equal to, it would be true, because 1 is less than or equal to, but it's not. It's a less than, this is false, and this third one would be a no. So 2 was a solution, 3 was a solution, 4 was not a solution. Hey, no big deal. That's a pretty easy concept. Simply sub in the value of the given domain and see if it makes the inequality true. That's all you've got to do. All right, let's think about graphing inequalities on a number line, and applies all values. Now look, here's the key, and I'll show you this in a moment when we do one. But all values below are the solution. Any value below your graphed arrow is the solution, or are solutions. Any value below are solutions. All right, so how do you graph? Very, very simple. If the variable is on the left, and you gotta put the variable on the left. Look, I can't tell you, I can't state enough how important that is, that the variable is on the left. I mean, it is just so important that that variable end up on the left. Okay, so make sure that your variable is on the left. So A, for a less than or a greater than, the number is not part of the solution. And again, I'm going to show you this in a moment. But the number is not part of the solution, so put a circle above the number. The open circle signifies that what is below it does not belong to the solution. However, if you have the equal to part, and that's B, right? Equal to part, equal to part. If you have the equal to part, then you put a dot above the number. The colored in dot, it's really that circle colored in, signifies that the number is part of it because that's the equal to part. All right, and then C, because, now listen, don't miss this. Because your variable is on the left, and only when your variable is on the left, but because your variable is on the left, the arrow goes in the same direction as the inequality symbol. Your arrow goes in the same direction as the inequality symbol. All right? So let's do a few of these. Need to get rid of my shade. All right, let me keep that so where you can see it. Okay, so let's do D, graph x greater than 4. All right, standard procedure, I will tell you this, is to graph it right on the number line. Here's the problem. Don't do this, but I'm going to use black. And let's just suppose I was going to graph, with a 7. And you're on homework, you're doing pencil, you're on test, you're in pencil. Is that real clear? And the answer is no, it's not. However, if I did the exact same thing above the number line, is that real clear? Yes. It's for this reason that I ask you to graph above the number line. So that's what we're going to do. All right, so I want to graph an x greater than 4. Okay, first off, I have to decide dot or circle. In this case, there is no equal to part. 4 is not part of the solution. I put an open circle above the 4. Now I need my arrow either going left or right. Well, my arrowhead points right because my variable's on the left, and I make my arrow point to the right. Here's what we're saying. The number 4 is not part of the solution. And let me show it to you. Go look over here where D is. If I sub in 4 for the variable, I get 4 greater than 4. Is 4 greater than 4? No, it's not. Now, what if I go to a 5, though? Is 5 greater than 4? Yeah. Is 6 greater than 4? Yeah. Is 7 greater than 4? Yeah. Actually, is 4.1 greater than 4? Yeah. Any value, 4.5 greater than 4? Yeah. Any value under this line is part of the solution. All the way up to a million, a billion, a trillion, and whatever other illion you want to come up with, all the way to infinity is part of the solution. Notice that there are a set of answers that are solution, and it's an infinite set. Okay, look at the second one. Graph n less than or equal to 5. So I got to go to 5 on the number line. I'm going to put a dot over the 5 because this time the 5 is included, the equal to part. And my variable's on the left, so my arrow goes in the same direction as my arrowhead, as my symbol. And again, any number underneath the line is part of the solution. All of those, all the way to negative infinity, is part of the solution. All right, look at F. Students miss F all the time. Why? I don't know. It's an easy problem. But, I mean, you got to go back up to here. So look at this again. If the variable is on the left, if the variable is the variable on the left? No. Okay. Now, some people can graph this, but for most people, their brain gets goofed up on these. Look, make it easy. Switch sides on this thing. Oh, and I'm in erase ink, so I better grab my normal ink. Just switch sides. Put the y on the left and put the -2 on the right. Now, it's an inequality. If you remember from last year, whenever you swap sides, you're trying to use the symmetric property. Equations are symmetric, inequalities are not. Whenever you swap sides with an inequality, you must reverse the inequality symbol. So do that before you graph the thing. All right, now it's easy to graph. Circle over the -2. And which way does the arrowhead go? To the right. So let me just show you this in the original. Would you agree that 0 is part of the solution? It's under the line. Okay, take your original inequality and put 0 in for the y. Is -2 less than 0? Yes. See how 0 makes the inequality true? And so does any value underneath the number line. But look, the key is reverse the thing, reverse the thing, reverse the thing. Swap sides, reverse the symbol. And then it's easy. All right, G. Oh, look at G. We got some negation. Yeah. All right, so what you want to do is you want to write the non-negated inequality first. Remember how to do that? We just did it a minute ago. You got your x, you got your 0, and what would the symbol be? And I hope you're thinking less than, right? So we have x less than 0. Okay, piece of cake now. Circle over the 0, arrow to the left. Okay? Not hard, pretty simplistic, and that's how you're going to do those. All right, number 7, intersection and union of inequalities. All right, we've talked about intersection and union with numbers. Now we want to talk about it with inequalities. All right. Here's how we're going to do these. These are compound inequalities, meaning 2 or more inequalities. And we're going to have a whole section on this later called conjunctions and disjunctions. But we're introducing it right now in this area here. So we're going to graph each above the number line and place the solution on the number line. Now you might say, Mr. Scarfy, you just told us a minute ago that if you're right on the number line, it's hard to see. Yeah, I know, but in this case, you got to put the solution somewhere. We're going to put it on the number line, and I'll show you that in a minute. Okay, intersection. What are intersection? Intersection is numbers, only numbers of both, right? Numbers that belong to both are intersection. If you think of intersecting lines here to the right, I'm going to draw a green line, and then I'm going to draw a blue line. Notice that the point of intersection belongs to both the green line and the blue line. That's intersection, things that belong to both. When you talk about number sets, we're talking about numbers that belong to both is the intersection. The intersection is numbers that belong to both. Okay, so let's do a couple of these technically conjunctions. So we have y greater than or equal to 0 and y less than 2. All right, so what we want to do is graph above. So I'm going to do black and blue here. I'm going to take my black. I'm going to graph y greater than or equal to 0. So I'm going to do a dot over the 0, an arrow to the right. I'm going to take my blue and do the y less than 2. Circle over the 2, arrow to the left. Now, what do they have in common? Well, look, it's this part right here, right? That's the part where you see both lines, where you see black and blue in those spots. Okay, so I'm going to take my red here for the solution. Is 0, does 0 belong, look at 0 right here, does 0 belong to both black and blue? Is black and blue lines above the 0? Yes. Anything less than the 0 belong to both? No. Anything less belongs to blue, but not to black. Okay, how about 0.1? Black and blue, yes. 0.2, black and blue, yes. 0.3, black and blue, yes. And see, now I'm drawing my red. How about 1? Black and blue, yes. How about 1.1? Black and blue, yes. 1.5, black and blue, yes. 1 and 3/4, black and blue, yes. 1.999, black and blue, yes. How about 2? Black and blue, no. 2 does not belong to blue, right? So we got to use the open circle. And we have just shown now that the solution to these two inequalities are numbers that start from 0 and end just before 2. So from 0 to just up to 2. Now, that's going to be 1.9999999999999999999 and a zillion other nines, right? And that's how you're going to show it. Let's do another one. All right, first one in black, n less than or equal to 0. If you want to, pause the video. You can try it yourself and then turn the video back on, see if you're correct. All right, n less than or equal to 0. So we're going to do a dot over the 0, arrow to the left. Second one, y less than -1, circle over the -1, arrow to the left. Okay. Again, if you want to pause it at this point and do your solution, see if you're correct, you go ahead and pause it. What do you see? Where do you see both? All right, well, look at -1. -1 belongs to black, but it does not belong to blue. But how about -1.01? It does. So we have to put the open circle at the -1. Now, how about -1.2? Does that belong to both? Yes. -1.5? Yes. -1.7? Yes. -2? Yes. -2.1? Yes. -3? Yes. -3.5? Yes. -3.7? Yes. -4? Yes. -5? Yes. -10? Yes. -a million? Yes. -a trillion? Yes. See the solution? You're putting the solution where you see both of the inequalities. All right, that is intersection. The second part is the concept of union. The concept of union. So I'm going to use my green here. And remember, union is put both together. Put both together. Dearly beloved, we are gathered this day to join this man and woman in holy matrimony, right? A holy union put together. All right, so union, put both together. All right, so we're going to do the same concept. I'm going to graph both above the line. X less than 3. Circle over the 3, arrow to the left. I'm going to take my blue, X greater than or equal to 4. Dot on the 4, arrow to the right. Dot on the 4, arrow to the right. Now look, these are all numbers that belong to either one. All that belong to the black, also all that belong to blue. The only way to say this solution, I'm going to do it in green because we're doing union, is to simply put a circle over that 3, arrow to the left, and a dot on the 4, and arrow to the right. This is a kind of an odd one for a union because when you put them together, it's still just the two original inequalities. It's because there's a gap and they don't overlap at all. There's no intersection of these. So the union is all the black numbers, also all the blue numbers, because you're putting them together in one group. Okay, look at the second one. It's a little bit more clear. X greater than -1. All right, greater than is a circle. Circle over the -1, arrow to the right. Take your blue, n greater than or equal to 3. Dot on the 3, arrow to the right. Now, what's the union? What's the union? Let me use the technology here. Let me catch this blue line. Let me put it down with the black line. Let me put them together. See what happens when I union them? See, the black inequality contained all of the values of the blue inequality. So therefore, putting them together simply gives you all the same values as the original black inequality. I mean, look, a 3, is 3 part of the black one? Yeah. Is it part of the blue one? Yeah. It's included. It was already including the black one. So adding blue really didn't add anything. Adding the blue inequality really did not add anything to this. It didn't. Now, if the blue inequality would have been lower than the black, then the answer would be the blue one, and the black wouldn't have added anything. union, putting together. All right, I know that's abstract. We're going to deal with that a whole lot more um, when we get to a chapter on conjunctions and disjunctions. Okay, so remember, know your symbols. Look, it's an arrowhead. Don't get hung up on trichotomy. Trichotomy is not that hard. Hey, there's three possibilities. They're either equal to, greater than, or less than. All right, sorry, I went backwards there. So they're either equal to, greater than, or less than. Hey, negation, make sure you know how to negate. Right? Make sure you know how to do negation and how to get the inequality from it. Talked about the domain, subbing in the domain, right? Not a big deal. And then how do you graph? Look, this is the thing that you cannot forget. Make sure your variable's on the left. If you do, it should be easy. Don't forget, circle above for less than or greater than. If the line's underneath, the number's included, then you put a dot above. Arrow goes in the same direction as the inequality. Beware of this one. Students often get it wrong because they don't bother to write the resulting inequality. They don't swap the sides and reverse the inequality symbol. Be careful with that. And then your intersection and your union. All right, that's the lesson. Hope you have a great night. Again, we'll work on this in class the next time class meets.